Hello all, I'm Juan Vuletich and I will talk again about Cuis Smalltalk. First, I want to start by thanking you for being here today. I want to thank FAST, Universidad Nacional de Mar del Plata, and the public universities in Argentina that host us every year for this conference. The Argentinian public university system is under attack from the Argentinian government, and it is important to raise our voice on every opportunity to defend them. High quality universities, open and free for all, are one of the pillars for making Argentina a world-class creator of science and technology. It is a duty of the Argentinian government to continue providing the funds to keep them strong. I want to thank you, Hernan, and other university teachers for using Cuis for teaching in class and spreading the word. Thank you, Maximo, for starting this movement that today means that Argentina is a world-class Smalltalk hub. Thanks, Hilaire, for Dr. Gio, and for the Cuis book. Thanks to the Cuis community for many contributions, useful feedback, and a lot of fun on the mail list and our monthly meetings. Thank you, Labour, for sponsoring this project. It's not me that you are clapping. You are supporting what I said. That's what matters. Okay. Cuis is an open source Smalltalk system. It's a direct descendant of Smalltalk 80 and Squeak. It is portable and runs on the open Smalltalk virtual machine. Most likely you all already know this. Nothing surprising here. So what else can we say about Cuis? The purpose of the Cuis project is to provide computer support for the creative spirit in everyone. Does that sound familiar? Yeah, those are almost the opening words of design principles behind Smalltalk by Dan Ingalls. So the goals and attitudes of the Smalltalk project at Park still inspire our work every day. Computers are insanely more powerful than they were when Smalltalk 80 was originally built. They are way more powerful than ever envisioned for the Dynabook vision. And computer platforms and systems are always getting bigger and more complex. The downside of all this is giving up our ability to completely understand what's going on. Sometimes it takes a lot of work to make something simpler, and that's our quest. Every Smalltalk system, both commercial and open source, has evolved following the priorities set by its users and developers. In this landscape, Cuis has a distinct set of priorities, and we have been following them ever since the project got started. A long time ago, while using Squeak for several projects, I realized that there were several areas where I felt that Squeak was in need of serious improvement. The Morphic framework made advanced UIs possible but difficult to code. Additionally, the transition in display technology from cathode ray tubes to flat panels made pixelation much more visible, creating the need for high-quality anti-aliasing. Also, the approach that was taken to support Unicode in Squeak put too much burden on developers. Finally, the class library had evolved without a careful design and became bloated and confusing. Fixing these issues was the driving force behind Cuis, and all this was essentially completed by the end of 2022. During this time, several projects have been based on Cuis, and as a result, many interesting and high-quality code packages have been written for and or ported to by its user community. So the list on the slide shows a small fraction of them. But If you come to Cuis from a non-Smalltalk background, or you are used to one of the commercial Smalltalk systems, you would expect some things to be really easy. Building commercial interfaces based on text fields, lists, and buttons must be easy, as in most other development environments. The same goes for building distributable applications for various platforms. But today in Cuis, you need to build the Cuis image for your application yourself. This is an involved process, it's not trivial, and still you don't get full control of what gets included in that image. And then you have to still package the image with a suitable VM and other supporting files in order to distribute your application to your users or deploy it to a web server infrastructure. At this point in the Cuis project, we are focusing on this different set of programs. We have already started working on the tools and framework needed for building end-user applications. So let me tell you about that. At the general system level, in these last couple of years, we have been improving the Cuis release process. Now we do stable long-term support releases of the system every 6 months, following a release process inspired by Red Hat Linux that is completely specified and predictable. Cuis is now distributed with a better folder structure. It separates system folders and files from developer folders and files, making it more comfortable to work on the files that hold your work. It also includes pre-made VMs and startup scripts. This makes for a much easier setup of Cuis on your machine, and it also gives you a useful model for the file and folder structure for your own applications. We have improved the code recovery tools used in case of a crash, making it convenient to review and reload your code. Based on feedback by the user community, we have been improving usability of various Smalltalk tools. And we are also working all the time on the system documentation, trying to make it good both for experienced Smalltalkers and for people new to Smalltalk. This is an ongoing process. The Smalltalk kernel in Cuis has also been enhanced with some new features. For instance, Bootstrap and precompiled libraries are essential for building distributable applications. Callbacks from libraries called via FFI and are absolutely needed in many cases. Thank you, Elliot Miranda, for helping us with this. Something else, when a debugger opens, this is involved. When a debugger opens, the debugged process gets suspended, and from that moment on, it's controlled by the debugger. Okay, it's no longer allowed to run freely. And when the user finishes using a debugger and clicks proceed, the suspended process gets resumed. But when the debugger is opened on a UI process, we need to schedule a new separate UI process to keep the UI alive and responsive. This new process is terminated when the user proceeds the original one, but is kept if the user abandons the debugger. And Cuis has an additional problem here, as the Morphic 3 framework uses additional data structures that would get corrupted if they are naively shared between these processes. It even gets worse. These data structures change in size if the user resizes the display while the debugger is open. And if they proceed, the old data structures held by the suspended process are no longer valid, and there is a serious risk of a system crash. So it took some significant amount of work to get all this working smoothly, without wasting memory by simply reallocating everything all the time. And this was done this year in 2024. We also added support for process-specific variables. Code was borrowed from Squeak, and an optional property table on every object, also from Squeak. And by taking advantage of Open Smalltalk's poor wide immediate character support, we unified the previous two separate character classes, simplifying code and improving performance. There have been, at the UI and tools level, there have been several enhancements to the Morphic UI framework focusing on supporting end-user applications. Modal morphs and dialogues. What do you mean by a modal dialogue? Assume that some regular code that is running in the UI process needs some input from the user in order to continue execution. It may be something as simple as prompting the user for their author initials or asking them to enter a class name to find. At that moment, the UI process cannot continue because it is waiting for the user input, but we still need to keep the UI alive. So, before a month ago, we used the same technique as Quick, that is running a separate UI morphic cycle inside the modal morph while we wait for the answer. This is not good. It duplicates code, it breaks encapsulation, and it's fragile. But the work done on debugger that I described in the previous slide gives a better solution. Use the morphic process scheduling machinery in the same way as the debugger does. This means simpler and more robust code and a really alive UI, including stepping morphs like the cloth, for instance, while using a menu. That's something that wasn't working correctly before. And this was also done very recently. So now making modal dialogues is much more convenient for the application developer. There have been improvements in morphic layouts, adding a padding parameter that is an additional colorless border to insert widgets inside a layout, and gap, that is the separation between widgets. These were modeled after CSS, so they will be familiar to many. And finally, we have included a completely new way to specify menus and keyboard shortcuts. It's now much easier for programmers to specify them, but it's also more flexible, allowing additional package code, for instance, to modify existing menus without the need to completely redefine them. That would be a lot of code duplication. Going back to our plans for the future and the needs of developers building actual end-user applications, these are some of the missing parts. We will be working on an interactive tool for building user interfaces by composing widgets. This is nothing revolutionary. Every other development tool have had this for decades, but in the Quick world, it was not yet there. We will also do a quality assessment on existing packages, so it's easier for developers to know how reliable they are before adopting them. And we will be building a small and nice runtime for applications based on a minimal runtime image that doesn't include development tools at all, and the dynamic loading of precompiled libraries. So all this machinery that I presented last year in our previous conference, we will put it to good use, both for modularizing the base quiz system, but more important, to make it convenient to build application-specific images, with the developer being able to control exactly what gets included in the image. We will also be working on a tool to generate the folder and file structure for standalone applications, both command line or server and interactive morphic. And we intend to support various package managers to distribute end-user applications, such as APT for Debian and Ubuntu, Yum for Red Hat, Homebrew for the Mac, and Chocolatey for Windows. So these are the main plans for the next year and maybe the next 2 years. Some other features we will be working on. We will add support for ephemerons. They have been supported by the VM for a long time, but we haven't integrated that into Quiz. We will take advantage of immutability. We have an immutability package since a few years, but we will take advantage of it, so literal object created at compile time will be immutable. That is a problem. Many Smalltalk systems let you create literals in a method, and then let you modify the literal via Smalltalk code, so it no longer reflects what the compiling method says. And that inconsistency is a source of bug and is extremely annoying. So using immutability for literals fixes that problem. We will support new work that is still being development, is still in development for doing non-blocking threaded FFI calls. And we intend to migrate to the new 6 terabyte code set. Both these tasks will be done in close cooperation with Elliot Miranda, who is the author of the VM support and all the machinery and the design of these features. So thank you, Elliot, again. We already have some planned enhancements to the vector graphics engine that haven't been included yet in the engine that is used by the system, because it requires building a new plugin and new VMs. So it takes a bit of care and a bit of time to get that stable and reliable on the official releases. But we will do this in the next month, I hope. This includes dashed lines and the possibility, more important, the possibility of having multiple nested morphs that can clip their submorphs. Morphic supports clipping to the arbitrary shape of any morph, not just rectangles, but the current machinery in Cuis can only do that for a single level. If you have an arbitrary shape morph that clips submorphs, a submorph of it cannot do that again. There is only a single level of that buffer in the vector graphics machinery. But we have a new design that is more powerful, that paying a slight performance cost for those morphs can do multiple levels, and that is starting to be necessary for applications. And I would also like to get back to work on right-to-left text for Hebrew and Arabic, and some other more exotic Unicode features. Unicode is infinite size specification, essentially. You never reach the end of what Unicode would let you do. And there are almost or definitely no implementation of Unicode that correctly supports every feature. So the Unicode support in Cuis support most of what everyone needs usually, but for instance, the main thing we still don't support is right-to-left text, and some glyphs substitutions and glyph order that are dependent on specific languages for certain scripts. That kind of more exotic things, we still don't have them, and we will keep working on them. So let me wrap up this short presentation by quickly repeating the main points. Cuis is an open source Smalltalk system focused on code quality and the original values of the Smalltalk project. It includes some advanced features not previously realized on any development environment. These original goals of the project became reality not long ago, and now the focus is on helping developers be more effective when building applications for their end users. Of course, without compromising the features that make Cuis unique. That's all. Thank you. I guess we have like 8 minutes for questions. I don't think if we will have so many.
Okay. So, okay, Unicode. What's wrong with this? When you say right to left support, it's right to left rendering or
Yes.
right to left handling, like I don't know, doing reverse and not losing clusters.
Right to left rendering of text.
Good luck.
Well, I understand where that comment comes from. You work on Vast, and I know that it's a non-trivial problem, but the machinery for rendering text in Cuis is very different from that of Vast. So the kind of problems that I will face will be different too, I expect. Okay. Essentially, in Quiz, we have control of the code that does that. So I hope we can make it work well.
Yeah. Well, in the case of Fast, it's Scintilla that does all the heavy
Exactly.
lifting. So
Yeah. So not here. Here the text layout of each line is done by a primitive, but that primitive can be made to fail in case of right to left text. So that makes it rather comfortable to start experimenting with a Smalltalk version of right to left text in those cases without slowing down everything else. So it can be done in the interactive Smalltalk system while it's running, and that perhaps helps a lot, I hope. No more questions. That's it. Okay. Thank you.